All right, here we go. A quick lesson on the introduction to logarithms, and this will kind of piggyback the short video you guys watched after the quiz last class. So I'm going to start by writing down a logarithmic expression, and you sort of saw these in that video. So I'm going to write the word log. That's short for logarithm. And we put this little subscript down here, and that is going to be the base of our logarithm. And then we have an input value that's going to go into the log function, and that's going to result in an output. And this expression would be read log base b, that's right here, of a equals x. So this is like what you plug into your logarithm with this base, and that's what the answer would be. And again, the question is a fancy way to ask what exponent, and remember, most of you got that right on the video. Exponent is the fancy word for logarithms. What exponent is required to go from the base of b to get a value of a. So what exponent is required to go from this base of b to get this value of a? So this answer to the logarithm is the exponent that you could put to this base b to get this value of a. So that's what we mean by it's a fancy way of talking about exponents. So in exponential form, just in words, we had a base. That base had an exponent, and when we raised that base to that exponent, it was equal to some answer. And in notation, we would say there's my base, I raise it to some exponent, and it equals my answer. And we've sort of done that unit on exponentials a bit, and what I want to talk about is going back and forth between the exponential form and the logarithmic form. So in a logarithmic form, I would have a log, and it would have a base. And the exponential answer would be inside my logarithm, and that would equal my exponent. And remember, logarithmic functions and exponential functions are inverses. Just like square rooting and squaring are inverses, so are exponential logarithms. So it's not a surprise that I'm switching the position of input and output, and then the input and output change places over here. And so in like this is actual exponential form as an equation. So logarithmic form is already up above, but I'll write it again. That's supposed to be the word log. I don't know what that little guy is there. Log base b of a equals x. Now I use the same letters because these expressions can be written from exponential to logarithmic and from logarithmic to exponential. The base of the exponent is the base of the log. The exponent is the answer over here, and the answer for my exponential becomes the input on my logarithm. So we're just going to practice converting between those forms. So you definitely want to have those down. Notice that these are all exponential forms, so I'm going to convert them all to logarithm form. So I'm going to start with this form right here, and I'm going to put it in the logarithmic form, which I sort of just covered up. There it is. So if I want to go from exponential to logarithmic, I have to write the word log, and I know I'm doing that because it says to a log. The base is the base, so I put that 1/5 down here. But this exponent is my answer, and this answer is my input. So these two things are always going to trade places in a log when I go from an exponent. So the base is the first thing you identify. There it is. That's my base. So this one would be log base 9. And then I swap these two. Doesn't matter what they are. I can put any letters or values over here. Doesn't matter. When I go from an exponential to a log, this becomes my input, and my exponent from my exponential comes out over here. All right, you take a second, pause the video, try this one. All right, video's on pause. Answer should have been log base b of 123 equals a. Again, this exponent, oops, goodness. That was quite a mess right there. Circled everything, didn't mean to. This exponent right here is what ends up over there as your answer. Base is always your base. All right, like I said, who cares if it's a negative number? Doesn't matter. Try it on this one as well. Okay, should have tried it. U is the base, so I would write the word log U. And this is my input. And again, my exponent, whatever it is going to come up and be the answer. And so this question is asking U to the negative 14th has to equal V. Now, I don't know what U and V are. I could put in a number for U, and I could actually figure out what V would be. And that's where we're kind of go that route in a minute. So last one, pause it and try it. Okay, this is your base. So you would write the word log base 8 of A equals B. And again, we're going to put some numbers to this in a minute. But first, we're going to do this process backwards. We're now starting with a log, and I have to write it as an exponential. So I have to have a base and an exponent. So I need a base and an exponent, and that has to equal my answer. And the base is always right here. So that part's never going to be confusing. The base of my log is the base of my exponent. So when I go to convert this, I have to write a U, and I have to put an exponent up here. But remember, in a log, the exponent's over here. So that output now would become my exponent, and that would equal whatever's inside my log. So again, inverse functions, the input becomes the output and vice versa. So this input of 15/16 becomes the output in my exponential. So B, there's my base. So I know I'm going to have 7/4. I'm going to use parentheses. And then this is my answer, so it becomes the exponent. Remember, the answer in a logarithm is the exponent, so that pops up there, equals whatever is stuck in my log, and that is an x. And so I could put a number in here like 2, and then I would square this, and I would have 49/16, and so that would make a true statement here. All right, try C. Okay, on pause. I'm getting bored of this purple, so I'm switching colors. There's your base. You should have had V to the 4th equals U. And sometimes I call this the circle rule. It's not actually a rule, so it's not an official math rule. But what you do is you take your base and you come over here, you swing around here, you pick up your exponent, and then you keep circling around to get back into the log, and you end up with your answer. That is my attempt at abbreviating the word answer. All right, try this one. Okay, hopefully you got 2 to the U equals V. Be careful with your U's and V's because they look kind of similar, but this is a U. Boom, it's right there as my exponent. And last one, give it a go. All right, base is Y, exponent is -8 equals X. So again, we kind of swoop over here, we pick this guy up, and that becomes our exponent, and this becomes our answer. All right, moving on. We're done with the page of notes. No time at all. Now, sometimes you're going to be horrified because, as you notice in these examples down here, there appears to be no base written. No base, no base, and this doesn't even say log. It just says, it looks like the word in. It's not the word in, I'll tell you that right now, but it looks like it. So we've got two situations. If you have the word log and no base is written, then you have to understand that that base is base 10. So it would be, it's like an invisible 10 that would be written right down here. And each of these would have like that invisible 10. You're not going to write it as shorthand. It's called the common log, and it is in your calculator, so it's a very nice one to know. All right, the other situation is this. When you see this, which is an ln, I often do it in cursive so it doesn't look like an I, and that is the natural log, also on your calculator, and it has a base of e. And e is a number very similar to pi. It's approximately equal to 2.718. It is on your calculator, so is the natural log, the ln button. And so when you see an ln, it is basically the same as saying, well, I have a log that's base e. So this one also has an e as the input, so that'll come back and we'll deal with that in a minute. But this ln right here is the same as writing log base e. All right, now we're going to try to answer these without a calculator and just asking ourselves the question that's been reiterated, and that is, this is going to be an exponent, because that's what a log is, a fancy word for exponent. So what power of 10 equals 10? So 10, this base, to some power equals 10, and that answer would be, hopefully you got that, 1. Very similar here. There's no base written, so it's 10. And so the question is, what power of 10 would equal 1 over 100? Now I have a fraction, so that means I automatically know this is going to be negative answer, and that would, again, then pop that up to the top. And what power of 10 is 100? That would be a power of 2, and so it would be negative 2. All right, you're going to try this one. Pause the video. All right. Question is, what power of 10 gives you 1,000? That answer should be 3. And this is a weird one because it's ln, so some kids like to just rewrite it as log base e of e, but the question remains, what power of e would yield in an answer of e? So e to what power equals e? Well, it's very similar to this one. That would be 1. So you're noticing if the base and the input value are the same, then that answer is always going to be 1 no matter what. All right, so here's some more to try without a calculator. We're going to do a few of them together. So what power of 4 equals 64? So sometimes I like to put a box. You're going to be like 4 to what power equals 64, because the base, this is my exponent, because that's what a log is. It's a fancy exponent, equals 64. And I'm pretty sure that's a 3. So this answer would be 3. So log base 4 of 64 equals 3, because an exponent of 3 applied to the base of 4 would yield 64. All right, you try this one. All right, hopefully on that one you recognize that that would be a 2, because 4 to the second power gives you 16. Same with this one. Pause and try this one. All right, here's your base 5, and I want to know what power of 5 would give me 125, and that power would be the power of 3. And you might not know all of these powers as well as others, so you may need to try to just check some powers on your calculator. Like this one, for example, that's my base, 343, and I'm trying to figure out what power of 343 would give me 7. And so that means that's going to have to be a fraction, because it's going to actually be cutting that number down. And again, I'm not 100% sure, but I'm going to guess maybe it is a cube root of 343 equals 7. So I'm guessing maybe that power is a third. So that's possibly the answer. You might want to check that on your calculator. I'm pretty sure it's right. So as we move down to the bottom half of this, again, this one is asking you a question that 3 has some particular power, and that will yield 1 over 243. So before I do anything, because the answer is a fraction, the exponent up here would have to be negative. So I know it's going to be a negative number. And what power of 3 yields 243? Again, you might want to play around with that on your calculator a little bit. If you're not sure, you probably aren't, but it is a 5th power. So 3 to the negative 5th would yield 1 over 243. So if this were just 243, then the answer would just be positive 5. All right, you try this one. Okay, 2 to what power is 4? Hopefully you got 2. You're going to try this one also. Pause it. All right, what exponent on 2 would give you 16? I believe that answer is 4. Again, 2 to the 4th equals 16. So notice how I can convert these. This is what we were practicing on the first page, back and forth between logs and exponents, and they both make true statements because they're flip-flopping each other. All right, last one. What power of 6 would yield 1 over 216? So you need to figure that out, and I'll put a big box up here. 1 over 216, so that 1 over 216 is a little bit of a hint. All right, so answer has to be negative, and I'm pretty sure that's the 3rd power of 6. I think 6 cubed is 216, but because it's in the denominator, it would have to be negative. All right, so notice that as we move on, and I'm going to try to finish this up real quick here, this is asking a question I can't answer. 6 to what power?